Title 18, Part 1, Chapter 10, Subsection 175, is entitled Prohibitions with Respect to Biological Weapons. It states that whoever knowingly develops, produces, stockpiles, transfers, acquires, retains, or possesses any biological agent, toxin, or delivery system for use as a weapon, or knowingly assists a foreign state or any organization to do so, or attempts, threatens, or conspires to do the same, shall be fined under this title or imprisoned for life, or any term of years, or both. It is also an additional offense to knowingly possess any biological agent, toxin, or delivery system of a type or in a quantity that, under the circumstances, is not reasonably justified by a prophylactic, protective, bona fide research or other peaceful purpose. Unfortunately, as clever lobbied lawmakers do, we can read that this exception, that is, prophylactic, protective, bona fide or basic research and other peaceful purposes, are also built into the definition of biological weapons. In other words, peaceful weapons, protective weapons, prophylactic weapons, and basic research into the weaponization of biological agents. Thus, as an excuse or exception to the law, we read Section C, the definition, which states that, for the purposes of this section, the term for use as a weapon includes the development, production, transfer, acquisition, retention, or possession of any biological agent, toxin, or delivery system for other than prophylactic, protective, bona fide, or basic research, or other peaceful purposes. In other words, with one sentence, the very definition of what a weapon is was split into two opposing concepts. One, a weapon of destruction and devastation, and the other, a weapon of defense, of peace, of basic research. While it is officially acknowledged that there is no difference between the actual research done in prophylactic, protective, bona fide, or basic research and that of militarized biological weapons for war purposes, what you are about to learn is that there is, indeed, an active biological weapons program within the United States, within corporations and universities, and throughout the countries of the world. This type of dual-use weaponization of bacteriological and viral pathogens is not to be found in the militaries of the world, but rather in the National Institutes of Health and other so-called peaceful, protective agencies, where this research of apocalyptic potential is done for the public good. The following footage tells the story behind the story of SARS-2 COVID-19. It's the story of cover-ups, espionage, greed, and maleficence. Most importantly, it's the story of a quite active and ongoing, internationally unlawful, and domestically treasonous biological weapons program hidden within and protected by illegitimate U.S. governmental agencies. It's the story of science gone awry, from the scientists involved in this type of dual-use, gain-of-function, and other bacteriological and viral weaponization research. And it is told here in their own words.
The part that was disconcerting was the tone and kind of acceptability among European life science researchers that what we are doing in the U.S. under the banner of biodefense, in fact, is thinly veiled bioweapons.
Well, the question I have to ask you, have other countries developed bacterial warfare ability?
Oh, certainly, Senator. That is one aspect of bacteriological warfare that the President's directive in 1969 and 70 tells CIA to continue, and that is to follow the activities of other nations. That we will see the capabilities and activities of other nations in this field. And we have some officers who do follow these activities abroad, and they are quite general. There are some very dubious areas where we're just not sure of what the actual capabilities are in some respects. But we do follow it indeed, and there is extensive effort done by other nations in this line.
But you are now prevented from...
No, we can follow the foreign ones. There is no problem with
but
that.
can you do anything to offset them?
Well, I think the defense against those possible things is a matter for the Department of Defense, Senator.
You feel you're safe in that field?
Well, I think in collaboration with the Department of Defense and advising the Department of Defense of foreign developments in this area, we are giving them the basis for developing such defensive efforts as we need.
Bacteriological and biological programs will be confined to research and development for defensive purposes, immunization, safety measures, etc. This does not preclude research into those offensive aspects of bacteriological, biological agents necessary to determine what defensive measures are required. Now, earlier you stated you thought it might have been the mentality of those who made the decision to keep these toxins, that they might be needed in order to develop defensive weapons. Do you think if that was their thinking, that it would be in keeping with the presidential order as I just read it to you?
Well, we looked at that. I think that you might be able to make a case for that, Senator, if you were actively involved and had responsibilities for these defensive measures. But as I think the chairman pointed out, the quantities maintained by CIA are difficult to defend under that.
And I believe the presidential order directed the CIA to continue to maintain surveillance of the bacteriological and biological warfare capabilities of other states. You say you have done that.
We do so, yes, Senator.
Are you in a position to tell this committee whether or not other states, and especially potential adversaries or enemies, now have stockpiles of such toxins?
I don't think I can say much about stockpiles, but I do know that there are installations which appear to us to be experimental stations of some sort.
Thank you, Mr. Cogan.
In the chemical field, certainly there are stockpiles. We are aware of that also.
Let me say that this imposes responsibilities on the Congress that I don't think we've always discharged very well. I can recall members of Congress who recoiled from responsibility of knowing what was happening. Members of Congress who said, "Don't tell me, I don't want to know." I think that is an indictment of the Congress, just as severe as any indictment which is labeled against any of the intelligence community.
And then in the biological area, there's the possibility of applying knowledge that's been acquired for improvement of public health towards the development of weapons to use to do harm.
Well, thank you. It's a real pleasure to be here today to talk about this, what I consider to be a complex topic, and I think you will see by the end of the talk I'm going to cover a lot of different areas. There are many different aspects that converge when talking about the dual-use dilemma, scientific, legislative, and I'm going to cover all of those and probably leave you with a sense of confusion and frustration about the current landscape, but also, hopefully also leave you with a sense about what the scientific communities and the U.S. government are doing to try and address this issue. We find ourselves now having to worry about the dual-use dilemma in large part because of the enormous progress that's been made in the field of molecular biology, genetics, and more recently genomics over the past 50 years. And we've seen how advances in these fields that are very much interrelated have produced some enormous breakthroughs in basic science, in medicine, in agriculture, and industrial processes. But at the same time, we're all aware of the fact that the ability to manipulate DNA, to essentially splice DNA into heterologous organisms and see gene and protein expression also carries with it a potential risk, and that is the possibility that these technologies could be used by some who are looking to do harm. And in particular, I think the concern here specifically relates to the possibility of using these technologies to create a next generation of biological weapons. And some have taken to calling these the 7 deadly sins. These were examples that were put forward of the kind of research that might cause some concern. At the time, this was a fairly comprehensive list. Any efforts to render existing vaccines ineffective, efforts to confer resistance to therapeutically useful antibiotics or antiviral agents, deliberately enhancing the virulence of a pathogen, increasing the transmissibility of a pathogen, altering host range, any manipulations that would allow for the ability to evade existing diagnostic or detection approaches for particular pathogens, and obviously the last one, enabling the weaponization of a biological agent or toxin. And I think that this was an area of concern that had been percolating among various scientific communities for a number of years. I remember very early on in the first discussions about microbial genomics initiatives on various key pathogens as to whether or not this sequence information should even go into the public domain, for fear that what those of us who were generating this information would be doing is creating a parts list that someone could potentially shop from. I'll take one virulence gene from column A and another from column B and put them together and create some sort of super pathogen.
And then, of course, you need all the components. All in all, we needed about 40 components. So about a dozen genes from yeast and Artemisia annua, and then all of the control systems around those genes. So promoters, ribosome binding sites, terminators, etc. And the balancing act for expressing all these genes is a pretty significant problem. You know, there's no BioShack you can go out to and buy these components. The way we get our components is twofold. The first way is through genome sequencing, and this gives us really a natural parts list that we can use. But remember, these parts aren't standardized. They don't have standard connections on them. They aren't characterized in any way. So you're using them, and you really don't know how they're going to function. So, there's a huge challenge here in that we have no models for any of the components and no standards for the construction and putting these components together to make devices that function. In genetic engineering, we've been practicing it for the last 30 years. And I'm not trying to put down biologists or this field, but many of the experiments are done as one-offs. You create a system that will allow you to produce a human growth hormone, and then you start over when you're starting with a different product. And the components aren't built with the idea that they'll be reused over and over and over again, and often aren't standardized. And I think that's one of the major contributions that we're trying to make in synthetic biology is characterize the components, standardize them so that they can be used more readily. So we're actually developing a biofab in the Bay Area. And the idea is to develop some of these components and standardize them, characterize them, and make them available to the community as open source. And we're going to be depositing these in a registry of biological parts. One has already been developed at MIT. I will see more and more of these developed. And then you use that characterization of those components in something like a BioSpice, a computer-aided design program that would allow you to design these devices. I think that parts characterization, parts repository, and parts registry will be the first components of a biofab, but certainly a lot of this is coming in the future, particularly robotic DNA assembly. And of course, this could be distributed all around the world, all around the country.
I think we all agree that these are very reasonable recommendations. My concern, as per the prior comments, continues to be, the long-term impact of this on the biosecurity, on the security of the United States, in particular national security. I ask you to do a thought experiment. Imagine that is the mid-19th century. Imagine that is a time of rapid industrialization. Imagine if you can convene a committee and it can anticipate things like pollution, can anticipate things like worker safety and all that, and you decide that you're going to put such nice restrictions in the system that you hinder industrialization. And now imagine how the 20th century plays out. Imagine the United States not having that industrial base for the world wars. So one needs to kind of think or to try to imagine that these are going to be the industries of tomorrow. And these are going to be, whether we like it or not, probably the weapons of tomorrow. And we need to be thinking in terms of this, also the national security of this country, which requires a lot of this work to get done. And if it doesn't get done here, it's going to get done in another place. And a non-industrialized United States worried about the pristine environment and all these things, we would have had a very different 20th century.
But one of the sets of experiments of concern that's not explicitly addressed here is the de novo creation of a pathogen. But I think that where we are now in a very short period of time, just 4 years following the publication of the Fink report, with the emerging field of synthetic biology, we are now actually facing yet another possible set of experiments of potentially grave concern, and that is not only manipulation of existing pathogens, but creation of pathogens de novo. And I will spend a fair amount of time talking about synthetic biology at the end of all of this. This term has been used in many different ways. It's been around since the 1970s to describe various areas of research. But I think most recently, when you hear the term synthetic biology used, it is being used to describe a new field that is cross-disciplinary and combines molecular biology, chemistry, physics, engineering. And the goal of synthetic biology is to actually create and study artificial biological systems, creating de novo organisms that are very effective in producing new drugs, new proteins for therapy, new vaccines. In the area of material science, combining organic and inorganic components to create new molecules that carry out specific functions, and engineering of biochemical and metabolic pathways. As you might suspect, there are a number of issues surrounding this whole field of synthetic biology. Some of the more extreme issues that have been proposed are, is this really a way of creating a roadmap for someone to engineer a super pathogen?
When the next biologic event occurs, and I'm absolutely convinced it will occur, we're going to have a better leg to stand on so that we don't see this draconian response back to let's sweep everything we do in the biologic sciences, back into the dark ages. The point for me is that today, if I use the term dual use, first of all, we basically defined it as the way we wanted to in this group first met. It's a term that I find not helpful relative to the big picture of dual use, because delivery systems clearly may be every bit as important as the agent itself, and that's part of dual use, but not part of our oversight.
But you could do DIRC on a non-organism that is not on the list. You could do it in MRSA, or you can do it in Salmonella, and it will not be flagged.
And there are others, certainly some watchdog groups have weighed in and have raised the question, are there ethical concerns here? Because does this mean that someone is essentially playing God by claiming that they are creating life synthetically? There was a whole interview that one can watch. It's a webcast where Drew Endy made this comment, but he himself has said that he expects that this technology will be misapplied, and goes beyond that to say actively misapplied. And so obviously that raises some concern on the parts of those who are worried about where this field might be going.
So I don't fully understand the reason why you're taking the approach that a code should be voluntary. I understand the argument about regulation, et cetera, but you've outlined all these terrific reasons why we should be abiding by a code of conduct, and there are many different ways the code can be implemented. I haven't heard one good reason why we're saying it should be voluntary.
I think that, how can I don't want to get in trouble here, so I'll leave out the Tea Party. But, there's a reason that recombinant DNA guidelines were labeled as such. Now, it's true if you wanted any money, you had to abide by them. But I think it was the notion that they were guidelines that made them much more acceptable to the community. And I think to the extent that we can promote the notion that codes are highly desirable and that everybody ought to be doing them as a voluntary activity, may well be more effective in all candor.
It'd be worthwhile really to ask ourselves, what the hell difference does a code make? I mean, take the Hippocratic Oath. Today, one of the most serious problems we have in medicine is iatrogenic-related events that are caused by doctors and nurses. And yet we have this code, do no harm. And when you look at the number of unintended consequences that occur because of really very preventable physician or nurse errors, you could argue you violated your code a lot. And I just come back to that. The reason is being because in the end, I think it really gets back to Mike's point. I mean, what you emphasize over and over again is what really does get acted on. And what tends to do that, first of all, is regulation or some punitive side of if you don't do it. Then there's that which is, okay, we're all required to do it, but if you don't do it, it's more peer pressure related that is going to be what comes to bear. Or there's that, I can't even remember what the code is. I mean, I got to tell you, Ken, I've been an ASM member for, I don't know, more years than I care to count, and I can't even tell you for sure what the ASM code is. Okay?
Those of us who are scientists know how scientists generally respond to compliance issues, at least psychologically. And the question is how the attitude changes when your responsibility changes and you become an institutional official. And so I'll be particularly interested. Two of them are microbiologists whom I know well, who are always responsible. But
as someone who has spent the past 12 years working in this field, I've had the opportunity to see firsthand how this kind of information can really accelerate the development of new diagnostics and new vaccines, to a lesser extent the identification of new targets for antimicrobials and antivirals. But at the same time, one has to be aware of the fact that there are some who view this information as a double-edged sword, because the information on all key human pathogens is in the public domain.
But I'd like to mention a few things that I haven't heard yet today that I think are important for everyone when thinking about the issues at hand. The first in my mind is that what we're dealing with are biologic agents. We're not dealing with nuclear weapons. We're not dealing with chemical agents. We're dealing with agents that reproduce, and someone with a minimal education can learn to grow and go out to Home Depot, in fact, and buy what you need, and go to your local slaughterhouse and find many of the same organisms that we're talking about, that these are available everywhere in nature, perhaps with the exception of smallpox, we hope. So that nothing that we do will ultimately be able to completely contain the availability of these agents to people who might want to do harm.
Projects that used to cost thousands and tens of thousands and even millions of dollars to do and take long periods of time can now be done quite simply with stuff that you can buy at Home Depot or order over eBay. The cost of being able to do research has dropped precipitously, such that now for hundreds or thousands of dollars one can do very small scale experiments basically in a garage or a basement. Can we come up with strategies for looking at the so-called do-it-yourself biology community who are, setting up either group labs where they rent space, and get together one night a week and kind of, play around in the laboratory, or even maybe working out of their own homes?
So basically, these are individuals who conduct biological experiments or play with biology as an avocation, not as a profession. They may have a day job in some related field, but they tend to do this on their own time, alone, or increasingly, particularly in some metropolitan areas, as part of a community. And there's even talk about putting together community labs. You see on the right what is a do-it-yourself lab in a sense. At the bottom there's a thermocycler. Then you have an incubator, which is basically a styrofoam box with an aquarium heater in it. And then you move up into this person's, young person probably's apartment cabinet where you have a number of reagents. And of course you have your basic towels and sheets on top of that. And below is a power tool which has been turned into a centrifuge to really to make things.
To what extent do these garage bio amateurs use commercial suppliers?
They clearly use commercial suppliers, and there is a whole world of like high school experiments where you can get an algae or a bacteria and maybe insert a bioluminescent feature. And so it does seem that this group has discovered that BioShack kind of approach.
I think occasionally an amateur may inadvertently end up working with a BSAT or something that would be considered dangerous, even if it's not officially qualified as BSAT.
I think there are growing concerns, though, that we hear more anecdotal stories all the time about people who have access, even in high school laboratories, who take it off on the side that just want to see if they can insert this gene here and do this, with the very idea that it's a risk issue that they don't perceive as having any public health implications, but they just want to see if they can do it. And I think that down the road, we're going to be confronted with more and more, and the real challenge is how do we find out about those?
This could serve as a way to focus in efforts to understanding what makes one strain essentially avirulent and another strain highly virulent. And so I think that's where we are with microbial genomics. As I say, these conversations have taken place multiple times. They're actually still going on, but in my mind, in many respects, this is far too late to be having these conversations. If there was really a concern about this information going into the public domain, something should have been done more than 10 years ago. This information is out there in databases around the world, and I don't think there's any way to pull this information back. All it might take is one catastrophic incident for the public to lose trust in what we are doing and for things to begin to spiral out of control.
These individuals are now not working under the same sorts of institutional oversight that we've been discussing so far today, for example.
So Mike, as you were talking, I was thinking, this group probably does need some input from safety, as I was looking at that centrifuge there, and and I thought about the fact they would like to engage in federal agencies, but of course as soon as they do that, they have all the regulatory burden that comes with doing that. So they may in the end not really want to take money from a federal agency if they want to keep having fun at this.
Yeah, at least hopefully they're wearing goggles. Well, yeah, I mean, the main thing we wanted to learn about the computer hacking community was what did the mainstream computing community do to try to discourage that type of activity? And it turned out that, a lot of the hacking was, not so much malicious, but this is cool to be able to find the flaw, right? And so, you can imagine the same sort of thing occurring, with biology. Well, it'd be really cool to find, something. Like when when I was a kid, I had a chemistry set, and it was cool to try to blow things up, That's kind of...
Mike, I think you ought to stop right there.
The question has to do with going back to the 1980s with a number of different treaties dealing with issues surrounding biological weapons. Is there any effort underway to now go back and relook at those and try and harmonize those? And take a forward-looking view in this current era of synthetic biology? The answer to the question is yes, there are small efforts in that regard, but they seem to be happening so far in a very ad hoc way. And as you know from what happened in the 1980s with these various treaties on biological weapons, there was no consensus then about what should be done. And I think we're kidding ourselves if we think that with all of the complexities that now are brought to bear on these issues, related to the field of synthetic biology that it's going to be any simpler to reach harmonization today, but there are certainly some who have been pushing for that to happen. Whether or not that will be a successful effort remains to be determined.
The part that was disconcerting was the tone and kind of acceptability among European life science researchers that what we are doing in the U.S. under the banner of biodefense, in fact, is thinly veiled bioweapons.
Dr. Trainer? With the post-exposure prophylaxis, because that's been brought up, I was impressed by the reports with SARS that many of those laboratory exposures weren't recognized at the time that they happened, and in fact some of them might have been very, very difficult, or even hard to understand now in retrospect.
But when you're posing the question, how to prevent a single event of catastrophic proportions of either happening or not happening, and counting on the data that are so, what I would call ambiguous, as to whether that is going to be the difference between the switch going on or off, seems to me to be almost by itself logs apart in understanding. And that if we really believe, as we do in 1977, that the H1N1 that we now deal with was in fact a laboratory accident that may have resulted in its appearance, we do have precedents to believe that this can happen. What's the risk we're willing to accept that this virus would be reestablished in the community in a catastrophic manner? Are we willing to say we're willing to accept 1 in a million, 1 in 100,000, 1 in 10,000? And I think most people would probably settle on, and whether you're a politician, whether you're a RAC member, whether you're a member of the media, I think we all may have different opinions on that, but I would bet that it's going to be very, very high. Well, this is like the power of any statistical study, to get to the level of data that would guarantee that someone on that particular approach, even given all the other associated protections that are being there, you'd have to have studies that would basically be impossible to conduct. And surely with the sensitivity and the specificity of what we have today for the kinds of treatment measures and the outcomes, I don't think they're even possible to do. This is not ever going to be studied to the point of where it'll provide us an answer. This is going to have to be about an understanding of what we're willing to accept as risk, and then what are we willing to do to take that risk of 1 in 1,000 to 1 in a million or 1 in a billion and eliminate it, or decide it's not that important, we don't care if we eliminate it.
We also know, we've done some work that we published in Emerging Infectious Disease, that CDC's guidance for preventing SARS in healthcare workers of how to don and remove personal protective equipment has never been validated. And in fact, when we did it with a non-pathogenic virus, we found, following the exact CDC guidelines, that in 70% of the time people contaminated their skins and face with a virus that was put on their PPE. So I don't think we can quantitate the risks, and we have to be aware, of course, with SARS that, you know, every case in the world outside of China came from that one physician who went to the Metropole Hotel. So the idea that one episode is sort of minor, might not lead to catastrophic consequences, may not be true, and I don't know any way to quantitate whether that risk is, as we just heard, is 1 in 1,000 or 1 in 100,000, except to say that the more laboratories that do this, and particularly if they don't follow rigid protocols and training and so on, you multiply the risks somewhat.
And we routinely and rigorously tell the community in the United States that these biosafety standards are adequate to protect them and to protect our workers, and quite frankly, to protect our research enterprise, which should concern all of us greatly. To me, it's very, very troubling and can have devastating impact on our ability as a research community to do emerging diseases work in the future, to be able to respond in a timely fashion to public health crises. But most of all, I'm concerned about what you do here today, or what decisions are made in the future, and the impact that it's going to have on the overall research enterprise in this country.
Dr. McCullers, you had a point you wanted to make, I think, before.
Yeah, so, well, in a quick answer to Dr. Wilson's question about behavioral changes, so
my people who work directly with the H5 pathogenic viruses know that the antivirals and vaccines don't work very well, and so they remain quite concerned about any potential exposure, and believe me, I hear about it at all hours of day and night about potential exposures.
Another important point that hasn't been made is that we all want to get to zero, but we're never going to get there. We can't get this risk to zero. And so no matter what you superimpose on top of this, you've heard that pre-exposure prophylaxis isn't going to work all the time. Dr. Monto's vaccine probably will work 95% of the time, but not 100% of the time, and so on, 70% in a bad year, 50% in a real bad year, and so it goes. I can't speak to the ethics about the first question. We ought to try to prevent every infection that we can with this virus and any other laboratory pathogen, but these two questions, as they're juxtaposed, don't exclude each other. So, I mean, we should try to prevent every infection, but we should be prepared to deal with it once it gets out, because eventually it's going to happen. That's what the bumper sticker says.
The 1918 H1N1 virus exists only in the laboratories, associated with significant morbidity and mortality historically in humans and in current animal studies, and is highly transmissible. In light of this, should the public health objective be to prevent any researcher from developing an active case of 1918 H1N1 that could be spread to the public, or is it acceptable to be prepared to contain the infection once in the community? Is our ethical obligation to protect the public higher because this virus was recreated in the laboratory, which we just talked about, but we will more, I hope. Scenario. A 1918 influenza researcher living in an urban setting becomes symptomatic and seeks treatment within 24 hours of developing symptoms. At that point, he or she may have been infectious for more than 24 hours. Would the circle of potential candidates be small enough to contain an outbreak? What if during the day prior to developing symptoms the researcher traveled by air or attended a crowded public event?
Quite honestly, I don't want to minimize the workers here, but they're not what's really that important. Because in a sense, what really is driving this is what if it would get out? And what would happen after the workers? And I think that that's the issue that really is before us here, is what would be the consequences of reestablishing potential another pandemic, and what that might mean. And again, none of us know if that would or could happen. So now let's take a step back and say, okay, this is not a big public health issue as we think of it, unless it happens, and then it's a mother of all public health issues. Okay, then we have a real issue. Well, first of all, if this is really a significant risk, and significant as I tried to define this morning, well, I don't know what's significant in any one of you. Is it 1 in 1,000? Is it 1 in a million? Is it 1 in 10 million? What's significant? Now we get to the issue, okay, it does create a double standard. And for those of us in the National Science Advisory Board, we've been trying very hard not to create double standards, because we believe the greatest damage we could do today is to shut down the science enterprise system. As far as the issue of a 1918 virus getting out, actually, David, I would agree with you. If we pick this up in the very earliest stages, it can happen. But I think probably more than anybody around this table, I have done more airplane emergency investigations where we've had MDR-TB patients who hacked for 8 hours on a cross-Atlantic or cross-Pacific flight, and I tried like hell to find these people over the next weeks, not days, weeks. And I've been involved with a number of these situations where you don't find them right away. So in your situation up here, I have no hope that we would find all the potential exposed people if there was an event like an airplane ride or a very crowded area. The second thing I'll tell you is it will create mass panic. If we then have to announce to unexpected or unintended exposures that you may have been exposed to this new recombinant virus that may kill a whole hell of a lot of people, because it sure did back in 1918, we will literally shut down large parts of the world as commerce, as public events, etc. It will be a major overreaction. And so we have to understand what that means. So we couldn't take that lightly. We couldn't just put out there like this, after also having spent, and I look at the time period of 24 hours, actually just after trying to find sexual contacts with some people after 24 hours, it makes me very convinced you won't find their respiratory contacts. Okay, so I think that we should try it, but I have no hope whatsoever that we will actually find all of them and capture them. So I think once this is out, it's out. And what's going to make the difference is what Mother Nature does. Will it burn itself out? Will it sustain itself? Will it be amplified? What will be the RO? In terms of the actual replication aspects to it. And so the bottom line is we can't ever let that happen.
I guess I want to tell you why I'm here. I'm here for two reasons, really. One is as a mom and as a person out here. I really feel that I have a gut feeling that I have to think and really consider this topic, because I have to look my children directly in the eye and explain to them that I was doing research, and my life was spent doing research in a field that possibly had some kind of adverse event, and I didn't do anything about it. That would be really weird for me if that's sort of worst case scenario. But I feel I should be able to say, well, we knew there was that risk, and I engaged in the arguments to try to work that out, if we should take such risks. So there's that. The other one is, personally, as a pandemic researchers, we know things can happen. We know that in 1977, the H1N1 virus came out of a laboratory from somewhere after having sit in a refrigerator for 20 years. So we know this can happen. We see the slips of pathogens every once in a while. It's not like a totally crazy idea that something could get out. So there's all of that. That's just very real to me. The other one is this fascination of that you have a pandemic, or our field is very focused against things we understand well, such as let's put all our effort to study influenza A pandemic threats, and then suddenly comes MERS and SARS and Ebola and what have you. I mean, we know we should be kind of humble about what we can accomplish and what it means, what we think we can do, and how safely we can do things, etc., etc. So, one thing that, for example, I didn't see on your list in the documents here is the emerging threats. We have influenza and MERS and SARS on there, but I'm imagining as the years go forward, you will be looking at new threats over and over again. For example, what about the Ebola threat right now? What if someone proposed a study to aerosolize this virus? Would that be okay or not? I just don't know the answer to that. If some of my family asked me, I wouldn't know quite what to say. I think it's super important to look at that and look into the future, what is coming down the line. Where are the red lines, you could ask? So I also think the issue of liability is a really important one. What if something was to happen and we have agreed that this research is to the public good? Then it should be clear what actually will happen then, what would be the, and also it's something else I've been wondering about is how good would we be at understanding if a threat actually came out of a laboratory, how good would we be at have a handle on it so we could find it and really claim it and say, okay, that was us this time. I mean, not that it will happen, but if it happened, it should really be an important part of it that we can separate the natural events from the man-made events.
But if I could just step back, 4 or 5 weeks ago, we held a meeting was held here in Washington. It was a small ad hoc group of scientists and non-scientists. We were 22 people and with 8 observers. The meeting was held at George Washington University. It was held under the Chatham House rule, so I'm not at liberty to tell you who participated in the meeting. 3 things came out of that meeting. More than 3 things, but 3 big things came out of it. Number 1, first, that gain-of-function research, especially experiments to increase the transmissibility of highly pathogenic avian influenza viruses, is a precedent-setting case study, for the regulation and oversight of dual-use research of concern and many other fields of genetic and genomic engineering, as well as synthetic biology. So there's a need to get it right. This is the big one, and we can't afford to get it wrong. The other thing that came out of the meeting, the second thing, was that because this is a high-stakes issue, it affects the entire world, there's a need for genuine public engagement. If civil society is not ready for this research, now this is taxpayer money after all, and if they're not ready for it and they're not going to go for it, then we should really think again. And as I said, we need to get it right. Now the third thing that came out of the meeting is that there are probably some red lines that can be drawn right now. So this is just for discussion. Where should some of the red lines, if we agree that some red lines should be drawn, just as Dr. Collins decided last week that there's a line that should not be crossed. So what are some examples of some red lines? Making Ebola, Lassa, or other hemorrhagic fever viruses transmissible by coughing or sneezing. I think everyone would agree that no one would ever want to do that, and yet it has been proposed. How about making HIV transmissible by coughing, sneezing, or skin contact? Again, very little support for that. How about making Ebola or rabies transmissible by mosquitoes? Both of those are conceivable. How about making highly pathogenic avian influenza viruses transmissible between humans? That we've been talking about all day. Increasing the transmissibility of SARS and MERS viruses between humans. We know that's controversial because the most people need an animal model. How about making influenza viruses resistant to vaccines and antiviral drugs? Or creating chimeric viruses that could be anticipated to have pandemic potential? Recreating extinct or eradicated viruses? Making drug-susceptible bacteria resistant to antibiotics, and that has come up at this meeting. And for example, making group A streptococcus resistant to penicillin. Group A strep is still susceptible to penicillin. It has been proposed that this be investigated. Making malaria resistant to artemisinin combination therapy, or increasing the toxin production of pertussis or C. difficile. So these are just 12 examples. I think there are several on there that most people in this room would immediately agree are experiments that should not be done. But if we just focus on the avian influenza viruses, which perhaps represent the greatest immediate threat in terms of, I hate to use the word catastrophe, but there is catastrophic potential if an engineered HPAI virus were to be released into the environment and into the community. There are 127 combinations of H and N avian influenza viruses. All of the ones in yellow, the reservoirs in ducks. The ones in orange are shorebirds. So 127 combinations. You could theoretically increase the transmissibility of every single one of those 127 combinations if you wanted to. We've only had 3 pandemic HN combinations in 100 years. And that's H1, H2, and H3. We've only had 3 pandemics involving avian influenza strains in 100 years. That's my last chart. We do have spillovers, and so the spillovers in red. Sorry, this is slipping. Spillovers are in red. And you know, H7N7 is the one that stands out. We've had a large number of cases. But in every single case, it's been dead-end infections. They haven't gone anywhere. So you know, why mess around with viruses that aren't going anywhere?
I want to address the discussion that was had this morning about the robustness of the existing process, by which I mean the process using the frameworks that was in place prior to the funding pause. On paper, that process sounds robust, but we have some historical record of how that process worked, one example of which was published and put online by Nature in the case of the IBC documents from the University of Wisconsin on the reconstruction of the 1918-like virus. Based on the characteristics of the process so far, I think there are several areas of concern that make this process that existed before the funding pause less than robust. The fact that the existing DIRC process did not flag PPP research as a separate issue until a confluence of accidents at prominent labs and public activism forced the issue is in itself concerning. Ironically, the extension by the Department of Health and Human Services of the framework to include H7N9 experiments appeared in the very same issue of Nature as a report of gain-of-function studies from the Fouchier lab, funded by the US government and not captured by the framework. More specifically, the present framework for H5N1 and H7N9 gain-of-function that was in place before the pause has the following areas of concern. First, expertise. Much of the responsibility for assessing risks and benefits under the current system lies in institutional biosafety committees. These committees are mainly composed of laboratory scientists and laboratory safety experts. These committees are essentially expert in occupational health. The difference with pandemic risk is that the risk is a public health, possibly global risk. IBCs do not traditionally include epidemiologists who might be able to identify what is a potential pandemic pathogen experiment or what the likely risk would be. IBCs are not well designed to consider such risks. If you read the IBC minutes from the University of Wisconsin that were posted by Nature, it is clear that in the absence of such expertise, the claims of the investigator are often accepted at face value. Most IBCs also have little or no expertise in biosecurity threats. Note that I am not criticizing IBC's fitness for their traditional task of dealing with occupational health risk of most pathogens in the lab. Instead, I'm criticizing their fitness for playing the same role in managing global public health risk, an issue that uniquely arises in potential pandemic pathogen research.
We're not so used to thinking about risk to the public. We're used to thinking about risk to human subjects. However, there have been cases in the past, as I'll talk about, where public risk has been a factor. And then, of course, the general public, it's hardest of all to inform them and get some kind of consent. So when we look at other research settings, we often require some kind of community or public participation on things like human subjects committees, IRBs, and the RAC and committees like yours. So would that be enough to provide public input and some sort of symbolic consent, or do you need more, as was mentioned earlier, what kind of transparency about public health risks is ethically appropriate? How do you supply effective public education on these very difficult scientific questions?
Is there an assumption that every gain-of-function experiment has to be considered from an ethical point of view, or is there a way, using some of the criteria that were presented today, to say that it's not really an issue in this case, and you get on to the biosecurity issues?
Something I wanted to throw in for consideration. I don't know what I think of it, but especially while we've got a bunch of ethicists in the room, because I work at the Department of State, so I know very few ethical people. But question is, we've tended to focus consistently on risk-benefit trade-off. In other words, in theory, any arbitrary level of risk is acceptable provided the benefits are in excess. The thing I wonder about is whether, in fact, there's a point where even if the risks outweigh the benefits, or even if the benefits outweigh the risks, if the risks are high enough, does the logic change? I can imagine having a magic quarter where if I flipped it, it came up heads, the entire population of the world would live forever without illness, age, or starvation. But if it came up tails, 50% of the planet would die. And I'm not sure whether we would assume that, okay, the benefits outweigh the risks, therefore go ahead and flip. So you can take the extreme case, but the question is there a point where that logic actually becomes relevant?
What if someone accidentally discovered a really easy way to make a pathogen every bit as deadly, contagious, and untreatable as smallpox? Surely no one should be allowed to publish something like that. It's not clear what the benefits of it would be, and it could be really dangerous if successful. At least it shouldn't be done in a non-classified context. I can imagine reasons for doing it in a classified context.
The question that comes to my mind is, should there be informed consent for the public?
If some sort of accident or security breach occurs and the public does suffer, that would be a huge breach of trust, and people will be very suspicious after that.
Yeah, so I wouldn't use the word informed consent, and I know you are struggling with it as well. I think that term is nicely restricted.
It's more communication.
Yeah, I'm right completely on your page there. I think there's really three things to keep in mind. One is this is 2016, and we now have probably 15 or 20 good examples just in medicine of the public being either misled, lied to, or feel that they were given misinformation about science.
It's not only that you actively request permission from the public per se, but I think to maintain the public confidence, I think that it's really essential that the public have a sense that they at least have access to information about what we're doing supposedly in their name, as opposed to having these things happen completely in secret.
We have been struggling for the last 40 years in the world of human subjects research to know whether the IRB system works. I don't mean it doesn't work. It does, as advertised. It reviews and decides whether projects should go forward. But as for whether it protects the rights and welfare of human subjects, we struggle with that a bit, because you may believe that you're protecting human subjects, or that you're protecting public welfare, or that you're promoting good science. But unless we develop the metrics, and guess what? That's where the next Nobel Prize in bioethics is coming from, how to figure out what those metrics are and whether they actually work or not, then I would recommend that you not adopt any kind of framework, because if you can't evaluate its impact, then there's no point in just putting it out there other than for public relations purposes. So I think you're making a moral statement as much as you are a science, or you're asking us a moral question as much as you are a science question. If I could just say one more thing, because it came up in the prior question, there is another example in the children's regs for human subjects research. Research that involves greater than minimal risk, but does not hold out the prospect of any benefit to that patient. So think about it. It doesn't exist in the adult regs, only in the children's regs. Greater than minimal risk, no prospect of benefit to that patient, but it holds out the possibility of generating knowledge about that patient's condition. So if you can wrap your head around those three conditions, so this patient right in front of me will not benefit. In fact, there is risk to them. So the risk benefit is risk, no benefit. But the justification for those kinds of studies are we're going to learn something about their disease, which is generalizable to other people with that disease. I'm not recommending that as a framework for this, but when you're doing the risk-benefit game, which is, you can't win that game, by the way. But the reality is we all have created this new paradigm of science in the public's interest, which is ironically being presented back to us with a mirror that says, look, we're funding you. We would like a return on that investment.
A question I have is under procedural value, one of the terms listed was accountability. And yet I didn't see much discussion around exactly how that is done. So let's assume something doesn't work out. Exactly what is the accountability for the investigator, the institution, the sponsoring agency?
I think what you're touching upon really is going to be a decision of the USG in terms of how they want to enforce whatever guidelines or regulations are a consequence of our advice. But I don't think we can get into the penalty phase very readily.
You guys are advisory to all the different agencies that fund life sciences research, and some of those agencies fund classified research.
In the physics literature, we never had this problem of whether or not you could patent a fact of nature, which has arisen in biology. So it's odd to me that you're concerned about patents, but you're not so concerned about the other.
Because there is less known about the coronaviruses, Griffin did find that some of the future gain-of-function studies could generate dual-use information that would entail significant risks.
One other difficulty is translating empirical studies on animals or in cell culture to epidemiological predictions for human populations is nigh impossible. If the incident does seed a local outbreak, about 20% of those would become global, would exceed local control. Speaking of the coronaviruses, increasing the transmissibility of the coronaviruses while increasing risk compared to wild-type strains of those viruses still creates pathogens that pose no more risk of a global pandemic than the 1918 influenza strain, but pose a much more significant risk than the wild-type strains of those pathogens. And also, it's an unresolved question if a laboratory-associated epidemic would supplant or supplement the annual toll in terms of morbidity and mortality of seasonal influenza. Would it basically cause 2 outbreaks? We don't know. For the coronaviruses, we found that wild-type strains are insufficiently transmissible and sufficiently susceptible to public health control measures such that a global pandemic has a minimal chance of occurring. I mean, and we've observed that in past outbreaks. We didn't have the SARS or MERS cases get into every continent in the world and constantly seed an epidemic that lasted for years. They were contained. So because this has a very, very small chance of occurring, increasing the transmissibility can significantly increase the risk of a global pandemic. This increase need only be small if the baseline is SARS coronavirus, but it needs to be significantly higher if it's MERS coronavirus. There needs to be a significant bump. But it only increases risk if it overcomes vaccination regardless of the antigenicity of the strain. So it has to overcome protective vaccination not by an antigenic shift or drift, but because of some way it modulates the human immune system so that no vaccine, even one specifically raised to it, would work.
These recent reports have made many of us question how effective the vaccines really are.
Now what we're seeing are actually mutants which are quite different from the original strand.
The authorities are still encouraging people to be vaccinated despite an increase in number of vaccinated individuals getting infected.
Vaccination doesn't provide 100% protection.
Let's now shift our attention to some pretty concerning news that's come in from Israel in what is being said to be a major blow to the efficacy claims of the Pfizer-BioNTech COVID-19 vaccine. Over 12,000 people who were inoculated with the Pfizer vaccine have tested positive for coronavirus in the state of Israel.
As the Delta variant, which originated in India, continues to spread across the globe, a new study out of India shows the Delta variant can be transmitted to people who have been vaccinated.
In fact, Delta variant behind most of the breakthrough infections. It's infecting, which means infecting after the vaccine jabs, as for the latest study.
Reports of fully vaccinated people becoming infected with SARS-CoV-2 have raised questions about the frequency and cause of breakthrough infection. Variants of concern, or VOCs, were responsible for 64% of those cases.
What if some of this research was being done in a different country where there's BSL-3 standards were more like our BSL-2 standards? How would that increase risk? As we divided out the data by varying assumptions about how strong community mitigation was, whether people just ignore it and conduct their day-to-day lives as normal, and in that case, community mitigation would be not. Or they extremely modify their behaviors and basically cut all social contact by half. It would be extremely difficult for community mitigation to be sustained throughout a year-long outbreak. You know, you could imagine people reducing their contacts by half or not going to school or work for a couple weeks, but not necessarily for an entire flu season. So robust community mitigation at this level is probably untenable once the outbreak goes global. Similarly, for the coronaviruses, you can see a sharp increase in global consequences at particular R0 values. All of these are within the realm of wild-type pathogens, suggesting that if local outbreaks of SARS, or SARS doesn't exist in nature anymore, SARS doesn't exist in nature anymore, SARS doesn't exist in nature anymore, a coronavirus like SARS were to occur and escape local control and constantly seed a global outbreak, it is likely that the strain would be transmissible enough already that global consequences would be contained. However, the probability of getting to this point significantly increases by more than an order of magnitude if the strain is made more transmissible. Also, it should be noted about community mitigation. You saw relatively robust community mitigation in the SARS and MERS outbreaks that have occurred in the past, especially in places like Canada where they were introduced. However, a global coronavirus outbreak, because of its relatively long incubation time and generation time, would extend across years, not just one flu season, not just 1 year, but many, many years. So this level of community mitigation would have to be sustained for a very long time. Now, the interesting thing is most of the biosecurity events that we identified as being high risk or likely to succeed involve the covert infection of the public. And because of that, it short circuits a lot of the controls that are in place on laboratory workers and for health monitoring. So should these events occur, they're a lot more likely to seed a local outbreak, which is much more likely to expand into a global pandemic. When you drill down, there's a number of traits that have significant dual utility for the various strains. One that doesn't have any dual utility, although that might be surprising to folks that study offense, is that because these strains are highly transmissible, the initial infections that would occur from an intentional event only have to number in the tens, if not even that, to spark a global outbreak, potentially. There's some phenotypes that you can't acquire, although there might be some dual utility in that if an actor was trying to produce an incapacitating strain. For the coronaviruses, there's a significant amount of information risk existing, simply because we don't have the tools to study these traits that actually do drive risk and have some significant dual utility. And for overcoming natural or induced immunity, once again, all of the, if you wanted a strain that was actually useful to cause more casualties in a surprise attack, you needed to make one that manipulated the immune system, not just was antigenically distinct. All right, so very quickly, the benefits. So for the coronaviruses, gain-of-function approaches that alter host tropism and enhance virulence are critical for the development of animal model systems that recapitulate human disease pathogenesis, which in turn are essential for the study of coronavirus pathogenesis and for advanced medical countermeasure development.
But I really think that the debate of the last few years has been focused on the creation of novel strains of highly virulent, highly transmissible coronavirus or influenza. And I think for the purposes of this debate, I would focus on those elements of the report. I think we would all agree that any global pandemic that occurred following any research experiment, if it led to a pandemic of any type above baseline, would deeply damage science and potentially harm or kill many. Where I was less in agreement, if I understood the report properly, was that the judgment that said even if coronaviruses were modified to be as transmissible as influenza, susceptibility of control measures would contain a majority of outbreaks. I think that's kind of a tautology. If a virus is made to be as transmissible as seasonal influenza, we know seasonal influenza is not containable, and so it's no longer possible to control it with control measures. So I don't think I agree with that statement. I also would say that we've talked a little bit about the importance of control measures with coronaviruses. SARS was controlled in the world, but only after an extraordinary series of global events. Many people in public health say that it was touch and go, whether it was actually containable, and it could have gone the other way. It crashed the Asian economy, took many months to contain. This is with only hundreds of deaths and thousands of illness. Big cities in the world in Asia look like ghost towns for periods of time. So I don't think even baseline coronavirus accidents should in any way be taken as events that we could easily or readily control. On the potential control of epidemics induced by accident or misuse, the report, I think it implies that human behavior can or may, I don't want to say will, reduce risk of transmission. In the case of influenza, we have a lot of thinking about that in terms of what we call social distancing or community mitigation measures, but there's no evidence so far that any of those macro measures make a difference in controlling influenza. So I don't think we should take any solace in the idea that human behavior is likely to control an influenza pandemic once it got started. My bottom line in this slide is, I think for our planning purposes, we should not assume that human behavior will substantially alter the course of a pandemic flu. Possibly it would with coronavirus spread, but again, not if it's made as transmissible as influenza. I would say that in my review of those who were interviewed for benefits, The majority seem to be proponents of this work or an institution supporting it. I would commend you to Stanley Plotkin's comments that were submitted to the NSABB, renowned global vaccinologist who goes systematically through the claims of benefit that are made by many and sharply disagrees with many of the benefits claims. And finally, in other notable elements, I think it's an important statement made somewhere, I think in the executive summary, that there are other pathogens that lie outside this framework that we're discussing that could be manipulated to cause a global outbreak. That's a stunning statement. So we're doing all this work, which is crucially important, but there are additional things that could occur that could initiate global pandemics, which we are now not grappling with as a government or a community.
There's a valuable modeling being done of laboratory-acquired infections occurring and outbreaks occurring relative to wild-type pathogens. But of course, without seeing any major outbreaks occurring with wild-type pathogens, what does this really mean? When I started working on HIV, people got infected in the lab with HIV.
The probability that a laboratory accident happens with a high pathogenicity, a high transmissibility virus, given that you're doing gain-of-function research, is infinitely higher than if you don't do the gain-of-function research. The equity arguments I saw in there all pointed to the developed world as being the one that was taking on the risk. I think this is just at odds with most people's perception of the issue, because it's the entire world that's taking on the risk of a pandemic. And it's not necessarily the entire world that's getting the benefits of the research.
You know, here I would expand it from flu and SARS and MERS to any highly virulent, highly transmissible virus that is associated with a high case fatality rate that is resistant to medical countermeasures. So what are examples of these gain-of-function experiments or the experiments that are under this deliberative pause that are of less concern? I think currently circulating seasonal influenza viruses, adaptation of coronaviruses to animal models, to mammals to develop animal models, improving the growth of viruses, mapping escape mutations against antibodies or drugs that are developed as medical countermeasures, and reassorting influenza viruses or spike swaps in the case of coronaviruses on attenuated or host range restricted backbones.
Doctors Barrick and Shi worked together to insert bat virus spike protein into the backbone of the deadly SARS virus, and then used this man-made supervirus to infect human airway cells.
A comment about the policy framework. The assertion is made that we have an effective policy framework. That may be true, but I don't think we have any evidence to support it. Effectiveness has not been demonstrated, and in fact, there are reasons to think it may not be. Of those, one is the fact that there are some clear conflicts of interest. We're sitting in a room here or standing in a room here that is managed by an institution whose mission is to fund research, whose director, we were told this morning, said that nature is by far the most important or effective bioterrorist, not man.
There are no animal influenza viruses that efficiently transmit in humans in nature.
A lab accident with even a minimally transmissible pathogen that does go global, or even a minimally pathogenic one that does go global, would be a catastrophic event. Even a small event would have catastrophic consequences.
If we are concerned about a global pandemic with the potential of killing millions of people, why aren't we doing this work under maximum containment?
I wanted to go back to something that's been raised by Susan Wolf and by some of the other comments about the excellence of a few labs. And I just want to reiterate the point that while those are truly excellent labs, the history of other truly excellent labs, government labs, in the United States is that pathogens get out not in the BL3s that are high quality, but to the BL2s because they are mistakenly thought to be killed. That happened at CDC twice over the summer. Under intense scrutiny, it happened again with Ebola on December 23rd. it happened 190 whatever times from Dugway Proving Ground. I mean, it is just not reasonable to focus exclusively on the laboratories that are, on what happens within the high containment laboratories that are superb, but also to think about the risks that happen over and over and over again at the top laboratories under intense scrutiny. And it's worth mentioning that the Purebright laboratory in Great Britain, which got obviously a lot of scrutiny after it released the foot and mouth that led to the widespread cases in the UK.
Which I think speaks to some comments that were made in the literature recently about the need for more robust data collection and reporting on laboratory accidents. We were befuddled by the fact, or not befuddled, we were stymied by the fact that those data just don't exist. And they need to be. After finding that risk is driven by human mistakes, we then admit that the specific rate at which those mistakes occur is highly uncertain.
You could very easily create a flu strain with new properties that has many features that might suggest perhaps it came out of nature. So you could the attribution problem could be very difficult if you did it smartly. And these sorts of studies might tell you exactly how you might do such a thing.
But interestingly, the technique that Dr. Barrick developed forces mutations by serial passage through cell culture that the mutations appear to be natural. In fact, Dr. Barrick named the technique the no-see-em technique because the mutations appear naturally. Nicholas Baker in the New York Magazine said nobody would know if the virus had been fabricated in a laboratory or grown in nature.
Now, of course, a few years after Asilomar, the Soviet Union, not believing that the United States was really going to abide by the Biologic and Toxin Weapons Convention that it signed, as did the Soviet Union, they established a top secret program involving tens of thousands of workers throughout the Soviet Union called Biopreparat. There was some consideration being given to aerosolize the Ebola virus, maybe link it to something like influenza. And this got people very concerned in the late 90s.
I would introduce a note of caution in thinking that it's all that much more difficult to work with pox viruses and do this kind of stuff in a malevolent sense than with flu. It's not all that technically difficult, unfortunately.
There is a plentiful, perhaps unending supply of pathogens which could either be directly misused or altered to cause harm. There are groups which have stated their interest or intentions in using biological weapons. There are certainly many opportunities to do so, and there are substantial vulnerabilities.
And I know the board is also looking for guidance. So when I thought about possible other sources of guidance, I was struck that the Biologic and Toxic Weapons Convention was not included in the discussion I've seen so far.
If you use a very narrow definition of biosecurity, meaning that someone's going to use the information or the resources of gain of function to produce an attack with a biological weapon, I think you'll find our risk assessment says that's not one of the major risks. The difference is our biosecurity risk assessment includes a variety of malicious acts that aren't biological attacks that end up having a similar risk in terms of human health consequences.
It seems to me that gain of function does fall under the heading of several of what the academies in 2004 called experiments of concern. The Biologic and Toxic Weapons Convention requires strong justification for pathogen development using any means. And so as a prima facie matter, it seems to me that both the Academy's report and the BTWC states parties would include gain of function research in their standards and recommendations. And actually, in the case of the Biologic and Toxic Weapons Convention, the U.S. is a signatory. And so as a matter of international law, we have to pay attention to it.
I don't know what's going on. It suggests that the working group itself wasn't even clear on how ethical principles are actually applied in reviewing research proposals. I don't think that's a message that you want to send as the world is watching this process.
It's incumbent then upon the board to provide findings about what is likely to be a productive and unproductive venue, which may mean concluding you don't go to WHO for this, right? This is where good innovation ideas in governance go to die, right? But if you're going to say that, well, is it the BWC process? Well, my understanding of that was another fairly unproductive talking shop about these issues, all right?
So one question that has come up repeatedly is who should be watching the chicken coop? In other words, the NIH, for instance, funds this type of research, obviously has a truly vested interest, and that's is the NIH then the appropriate organization to provide the oversight of this kind of question that we're discussing?
In the end, I think the question's answered for you, which is that the funder decides whether to release money or not. So that's HHS. A lot of what you've been talking about here has potential implications for the safety of the people who work in the laboratories, has implications for the local environment, non-human environment. We have in other settings, and I'm more familiar with genetic settings like gene editing and such, we have a long history of the public making assumptions that things that are naturally occurring are less likely to be dangerous. They're somehow spiritually or physically somehow purer and better. This may just be a temporary phase in U.S. I mean, in the 1950s, if it was plastic, it was better. Now, if it's natural, it's better. And of course, we all here know that that's not true, right? It's very context specific, what is better and what is worse and what's safe and not. In the nanotech field, you know, some areas we're pretty confident there's no issue at all, and then there's others where we're really not sure what would happen if you had aggregation of these nanoparticles and things.
Yeah, I mean, not much to add to that. As biology has become more experimental, the challenges, cultural impressions about what counts as life and how far you can go, and you know that may be a multi-generational challenge. Sometimes when I see the videos that are online of the crazy stuff that roboticists are doing, and how much fun they're having, and how, you know, making these little creatures, and they fly around and they swarm, and you can control them and do crazy things with them. And people find that very amusing and fascinating. But if you were to do that, you know, with bugs, biological creatures, that does set off something in people that is a little different. I'm not sure exactly why that is. DARPA sponsored in Brooklyn some years ago called the Robo Rat, where, if you remember, you know, they basically put some electrodes into a rat. Steve and others remember this well, and they got to control. They made the rat do things rats don't ordinarily do, like climb a ladder and so forth. And when I show that to students, even including people who are going to medical school and, you know, science undergrads and so forth, they're creeped out about it. But if you made a little robot that did that looked like a rat, or roughly the same size, or maybe the size of a computer mouse, I think they wouldn't get creeped out. So there's some interesting cultural sensitivities here. As Alta says, I haven't figured out what to do about them.
Now, the real challenge in the U.S. is not physical harm. We're comfortable with that. We regulate things against physical harm to the environment, to humans. The real battle in the United States is whether or not moral outrage counts as a harm that allows you to forbid things. And we have not decided that yet. We're still dithering about that, and it's crucial in the synthetic biology area, where they want to create things that approach the notion of life to the point that it offends a lot of people, but doesn't necessarily cause any kind of risk. And it may be true to some extent here. But that's where the battle line here is going to be drawn.
It appears that our Frederick County Health Department hasn't participated in any way, shape, or form on this session, nor has our state Department of Health and Mental Hygiene. The state level appears to want to avoid all issues in Frederick County, and I think you ought to all know that. So I have three speakers I'd like to ask questions for, two, and one is Dr. Casagrande. Use of terms. Used the word weaponeer yesterday, and I interpret that to mean evil people, because we, by treaty, can no longer develop weapons. But although we have to do countermeasures, we will have weaponized pathogens available. And if that's a correct understanding, then I'm on board. Dr. Burns referred to Sorry about that. My experience in these 5 years, at any time we tweak the button or try to peel the onion in government, we're shut down. So I have no confidence in the Frederick level that we really have our act together. In fact, I know we don't. In a community near Frederick, I discovered a Russian BSL-2 lab sitting next to a children's center. And when I started to peel the onion, guess what? Website, hazardous material. So I started to take it up the ladder, and guess what? They moved. So that's what we're dealing with. And we need help. Thank you.
The reason why this stuff gets killed is often because of perception, not reality, number one, and public perception matters. And the other is that it has to do with foreign impressions of what the United States is doing. Right now, 50% of our allies think we have an offensive bioweapons program. 50%, about, plus or minus. We don't. We haven't since, believe it or not, Nixon abolished it, what, in 1969, okay? I wasn't in position previously where I would have known if we had an offensive program, and we do not. So if 50% of our allies, our NATO allies, believe that we have an offensive program that's secret, we have to be very careful with what we do and what becomes public, because defending against bio threats by developing countermeasures looks a lot like an offensive program.
I wanted to follow up, though, on your very last statement about the scope of the research that's being reviewed. And you said federal government. Is that a correct statement, or is it only HHS? And today, a lot of work is being funded by non-HHS agencies, and I'm wondering, are this work being included in the review?
Right now, it's come out of HHS funded work.
Is there a discussion to broaden the scope so that DARPA and others might use this review process?
For the most part, they don't get involved in the type of work that would fall under this. They, for the most part, a lot of that is enabling technology, but actually modifying, dangerous pathogens. But maybe it's worth a double check on that. And the look on your face, maybe you and I should chat offline about it. I should point out the committee itself, the group, is not all HHS employees. So we do have defense.
So a little bit about the history of Fort Detrick. It was called Camp Detrick. In 1943, the research program began, and as many of you know, the U.S. had an offensive biological weapons research program. There was an element of that called the U.S. Army Medical Unit, and their job was to look at medical countermeasures, pathogenesis, et cetera, with the idea of protecting warfighters and also people in the labs. So in 1969, when then President Nixon abolished the old program, as we call it, USAMRIID was established with the roots of the Army Medical Unit. And so our mission has always been about biological defense. There are 2 other containment labs on post, as some of you know, one belonging to HHS, one to the Department of Homeland Security. USAMRIID also has a whole layer of Army and DoD oversight.
So the most important part of the international framework that you need to consider for this type of research is the rules and our compliance with the Biological Weapons Convention. The BWC, in case you're not intimately familiar with it, it's been around, it's been in force since 1975, and all the nations that are part of it agree to not make biological weapons or and use them. And as part of this process, there is something called a confidence building measures, where nations put forth research and facilities that have potentially dual-use characteristics, that since verification is such a difficult thing for biological weapons, which can have such a small footprint, you have this process where you share information about work that's ongoing that could lower barriers to biological weapons development. So classified research is permitted, of course. There is classified research in biology, but it is controversial, particularly when it becomes revealed in dramatic fashion. There's also the UN Security Resolution 1540, which is not as important to you, but it's just for completeness, nations agree that they will do what they can to prevent non-state actors from misusing biological materials as well as other WMDs. So on the domestic side, the most important thing for you to be concerned about is the National Security Decision Directive 189, which came about in 1985, and it was focused on Eastern Bloc, Soviet Union, taking science and technology advances put forth by the United States, S&T enterprise, and using it for their benefit. Is this really lowering barriers to biological weapons? Actually, that's what the focus of the Jason's report is. Okay. And because the question of collaborating with scientists from other countries and whether the security and economic implications. And they basically said, there are these problems where the research is misused for economic benefit or, taken. The NSDD 189 came directly out of a National Academies of Science report, and they came very much on the side of openness in this report, saying that what the United States should do, what the larger security benefit to the United States would be, is to have security by accomplishment, to have a robust, vibrant research enterprise that was based on openness and good scientific principles, and that the benefits to security for the U.S. were greater in that openness and embracing the research enterprise. Again, there are places for classified research. Classified research is done in many different places in the U.S. I mentioned NBAC as one example, where threat characterization research is done that's fueled by intelligence considerations and to better characterize the biological threats that we may face. On the right there is part of the World Health Assembly, which is the governing body of the WHO. After there were some SARS laboratory accidents, they came out with this ruling basically encouraging nations to beef up their lab safety.
I will also add one of the things about the process is this only applies to federally funded research. University-funded research does not fall under the current framework. What vulnerabilities exist there?
Finally, there's a number of things in question. Maybe this is its own framework, who the researchers are, the urgency of the threat and what the research is trying to address, the danger that the information could be applied toward a biological weapon. All of these factors will influence whether something is funded or not, and different times may lead to a different conclusion at the end of it. I always thought it was interesting that the sequencing and subsequent synthesis of the 1918 flu virus, it wasn't as controversial as some other synthesis experiments, I think because at that time there was a lot more concern about flu and there was a lot more acceptance that this research needed to be done.
The origin of the NSABB came from a reaction to the Fink report. It was done in 2003. I forget the title of that one too, but it's usually referred to as the Fink report, which outlined
biological research in an age of terrorism.
Thank you, Carrie. And it had these 7 categories of dangerous work that could potentially be used in a terrorist event or by bad people, and they called them the 7 deadly sins, if you may recall. The problem with the report, as was seen, I was at the White House at the time, that was seen by us, was not that it didn't outline the dangers, but it might have restricted research. The intention was to allow a deliberative process to make sure that some of those 7 deadly sins, which were quite marginal and are used, some of those techniques are used all the time in order to create beneficial products and countermeasures in vaccines and drugs, were not stopped. So it actually started off as an enabling group, not as a restrictive group. But I say that mainly as background because too often I think people look at groups like this as how can science be restricted? How is the government getting involved in our affairs? How are they stopping me doing good science? And that was not the original intent, and I don't think it needs to be the intent of this group in any way.
In 1977, the influenza virus that circulated that year was definitely not natural because it was identical to a virus that came about in the 1950s, and there's a lot of debate in previous gain-of-function discussions of what was how that came to be, and in that paper we go through some of the different scenarios and come down on probably it was the result of a vaccine trial that went very seriously awry.
So there's one aspect of it is these are things that have to do with defense and they should, but there's another aspect of it that I believe is that is related, and it's related to this merging of basic academic research and the private sector.
Right.
And so CUI also applies to if you're a company and you are going to make a product someday and make a profit, CUI also applies to that. And so I don't really have a question, but there's this merging of academia with the private sector.
During the Ebola outbreak, there was about an 8 to 10% drop in the market. It then quickly recovered. I wanted to give you good news. There are winners out there, right? So if you want to be prepared and make money in the next pandemic, if that's what you want to do, buy stock in hazmat suit makers and protective clothing or companies that make antiviral drugs for that particular pandemic. You'll probably do pretty well. There are actually mutual funds for pandemic preparedness. You can bet on anything in this country.
I mean, a lot of the claims about the benefit of this work relate to its value to vaccine development. But typically over the last 8 years, we've had very few, if any, vaccine developers at these meetings are taking a position. Why is that?
A colleague across the way can comment more, but you just talked about an issue, and essentially there's also the issue of bioerror, which you just enunciated when you talked about the vaccine development thing.
The vaccine trial that went very seriously awry.
You know, the risk from minimal to apocalyptic, and the benefit from, increasing academic knowledge all the way to curing, the ultimate influenza, universal influenza vaccine.
And that's going on in the private sector. Mm-hmm. So you have inadvertent problems as well. That's something actually that worries me almost more.
A lot of what we're doing here is becoming increasingly restricted, first to enhanced PPP, which is quite restricted, and then U.S. government funded, which is now becoming a smaller and smaller percentage of the amount of funding that's going into biotechnology research. Given all of that, do you have any comments on that part of it? The fact that no matter what we do here may be increasingly irrelevant? We're coming up with a set of ways, oversight to look for dual use, right, whereas the private sector has no reason to adopt any of our recommendations if they're not taking money from the U.S. government, and not to mention foreign actors.
And also, you mentioned the horsepox virus, and the investigator there was in Calgary in Canada. And therefore, privately funded, so none of our regulations apply.
It's nothing's ever eradicated as long as you have the sequence, right?
In the past 10 years, rather than having the majority of submissions to the journal be from U.S. laboratories, 60% of our submissions now are from international laboratories, and only 40% are from the U.S. And when a group in China says that they have met the conditions of the Chinese Institutional Biosafety Review, we have no idea what that biosafety review is.
Troubled by. Also, I'll tell you a scenario where a paper was reviewed at one of those journals, and one of the reviewers requested a BSL-3 experiment. And the author of the paper didn't know that it was a BSL-3 experiment. And let's just say, for the sake of argument, that that person was in a foreign country and the drive to publish was so high. I think we're going to see more of that. And I was shocked. I contacted the editor of the journal, and I don't think they were even sufficiently knowledgeable to know that it was a BSL-3 experiment.
There has been a lot done about responsible communication, but if you really read what is being said, often in the NSABB deliberations earlier, responsible communication there is make sure that the scientists who are doing the work describe it in a way that doesn't alarm the public, which is useful, but it also could be seen as, in the worst case, it could be seen as spin.
I think we should think about whether the public cares about transparency at this stage. I think when the work is done, they want to see it and know the impact for their lives. So the process of deliberation in the H5N1, as a scientist, as I said, I was okay with it, but I don't know what people would think. And if they don't care one way or another, I don't know how you get that information, but that's important. My colleagues here, they want to see more transparency, and I understand that, but we're not going to do it for two people, right? We're going to do it for the public. And I'm just not convinced from what I hear that they want to know at that stage what your deliberations are to let this work go forward. I think that's something you need to find out somehow.
But if you're saying these are diverse coronaviruses and you can't vaccinate against them, there are no antivirals, what do we do?
Well, so I think that coronaviruses are pretty good. I mean, you're a virologist, you know all this stuff, but you can manipulate them in the lab pretty easily. It's just spike protein drives a lot of what happens with the coronavirus, zoonotic risk. So you can get the sequence, you can build the protein, and we work with Ralph Barrick at UNC to do this. Insert it into a backbone of another virus, and do some work in the labs.
I mean, we don't know what we don't know, and that's just fine. I mean, when you get a new drug, don't ever read that package insert, okay? Or you definitely won't take it. Sometimes when things are doing just fine, is when you really hear from very few people, and the people you hear from are the crazies out there. And we all know, I mean, there are a lot of crazies out there.
And in response to the comment about if the public gets involved, nothing will ever be approved, I think I want to clarify, I don't think anyone has called for an open public hearing with anybody just coming up to the mic and offering their comments.
The experiments we're talking about here, again, this is a very, very small subset of potential pandemic pathogens. Those experiments were not disclosed to the public, and the review process was not disclosed to the public, and that's what we're talking about. We're not talking about it being kind of outside of any regulation. There is regulation, but that gets to the second point, which is even in some of the country's best laboratories, there are accidents. In the last 5 years, there have been 2 accidents at CDC, 1 accident with anthrax at DOD.
There was an article by one of the Dutch biosafety regulators reviewing the global situation, and their estimate was that I believe less than half of accidents get reported.
I can just give you a random denominator that I remember. There was, some 25 plus incidents reported by an entity a year. But we noticed that the BSL-4 entries that year were over 50,000.
I agree that there is not a lot of data when it comes to accidents in the laboratory, and that is people do not want to report for a lot of a lot of good reasons. Nobody wanted to go on record of having TB accidents in their facilities. So it inhibited and put people at risk.
The 1 in 1,000 or 1 in 10,000 chance of infecting thousands or millions of people is a really bad thing, which no human ethics board would ever say was acceptable. It's just that this is not regulated by human ethics boards.
What we're talking about here is the government funding and approval process for research that is intended to create transmissible virulent agents, which, if something goes wrong, either by accident or on purpose, could initiate an epidemic or a pandemic. We were concerned that specific experiments had been restarted under this HHS framework, but had not been announced publicly or described or justified. There was no public description at the time of January of 2019 when individual experiments were disclosed after a reporter asked the government for details. So the government did not disclose that those individual experiments had resumed. So this is a very, very specific area of research. This is not all dual-use research. It has nothing to do with the broader coronavirus research agenda. So today I've already heard some kind of aligning of the two. Mark and I, for example, are very supportive and strong advocates for coronavirus science. Maybe that the U.S. is the only government funding this, although we've heard that in past years we've heard that China and Wuhan had done some work around flu on this. That's old news. I don't know if that's still going on, but in any event, we don't have international consensus about how to operate here. And as I think Chris was saying, or maybe Kerry was saying, that since we are leading the effort here, or funding more of it than anyone else, it should be incumbent on us to initiate or continue, it has been initiated but then stopped, any discussion about how we should proceed internationally. Don't we want other countries to operate under the same rules that we do? Would we be upset if we, for example, found out today that some other country was doing coronavirus research to create more pathogenic or more transmissible coronaviruses in the absence of some very clear set of international standards?
We're talking about regulating extremely smart, creative, and motivated individuals. Currently, animal research and high containment laboratories are proliferating in China, for example, in part because there is not as much red tape as in the US.
Just two quick things and direct follow-up. To your point, Jim, worth reiterating that the OSTP policy guidance essentially directed departments and agencies to come up with a review process. HHS was the first out of the gates, and that's the sort of review process that Chris is describing, which applies only to HHS-funded work. Other departments and agencies would have to speak to their own sort of review processes. To the best of my knowledge, I don't know of any that are in place, and I strongly suspect, at least at the time we were having these discussions, that was because this work was solely being funded by HHS.
But the actual proposals are all NIH or all NIH and NSF, or is it just?
Today it's all been NIH.
All NIH, yeah, that's what I saw.
Who chairs the group? Can you say that? And then is there a higher level authority that approves the committee's recommendation?
So I chair the committee. The decisions go, there's a letter that's signed out from NIH that ultimately goes to OSTP. Those people are identified. So Dr. Drogemeyer at OSTP is the ultimate signatory. The first two, Tony Fauci at NIAID, signed the letter to Dr. Drogemeyer.
I suspect part of Tony Fauci's expertise is he has mastered a lot of those technical issues, so he knows how to explain those things as well as staying within the boundaries. But as you suggested, the scientists, somebody who toes that line will then be undermined by the sloppy handling of the political decision making. As I understand it, is following what's going on in China. They tried to do a bit more open job than with SARS, but they didn't, and then it got chaotic.
How do we know that any gain-of-function research or something that could be interpreted actually gets into the P3 NIH process? And we saw from the emails that there were no coronavirus work that actually got into the process, so there's an intake issue.
How it does the P3 framework, it's my understanding it's an oversight board that is there to decide if you are in fact going to fund any gain-of-function research. Is that right?
That's what the intent is, but how it works, how research gets taken into that, it's unbelievable to me that coronavirus work would not get even into the process. If you look at the abstract from the latest grant
Yeah.
that was done to EcoHealth, it talks about using protein sequence data, infectious clone technology, in vitro and in vivo infection experiments. This is all gain of function. How
Right.
this could not get into the P3 process is unbelievable.
And as far as I know, there's never been a grant that's gone before this structure, the P3, despite the fact that it was set up. So it was set up to look for gain of function research, and my understanding is that there's been no grant that's been sent.
Well, my understanding is the guy who heads the chair of this board, this P3 framework board, is Dr. Hassel, and he's even said in a public forum, he volunteered this information that he's the chair, and he said it's been very limited, the work that they've done. Very few proposals come in front of them. But I think maybe the big takeaway for us today is the people responsible for making these decisions, Dr. Collins, Dr. Fauci, we invited them, they wouldn't come. And then the guy who chairs the board, Dr. Hassel, we invited him, and he wouldn't come.
The very nature, the very name of our committee is the Select Subcommittee on the Coronavirus. And yet, not a single hearing on the origin of the coronavirus. Well, that changes today.
Dr. Fauci was on notice on February 1st. Actually, take that back. He was on notice on January 31st. We got the email where one of the scientists who gets American tax dollars sent him the email and says, the unusual features of the virus make up a really small part of the genome, so one has to look really closely at all the sequences to see that some of the features look engineered.
SARS-CoV-2 was pre-adapted for human-to-human transmission from the very first patient. Specifically, the part of the virus that interacts with human cells was 99.5% optimized. I mean, there's additional fingerprints inside SARS-CoV-2. For example, there's 4 signals that I'm looking at, which one of them is an area where it looks like it's designed to kill cells more easily. One area looks like it's designed to plug up a hole in the nucleus to prevent interferon from coming out. Why is that important? Because then you're asymptomatic. You don't sweat and get a fever from the virus, you get it from the interferon. One site looks like the spike protein was actually humanized so that the immune system wouldn't recognize it, to make it even harder to make a vaccine against it. And of course, we have the furin site, which makes it highly infective. So how do I believe the COVID virus was taught to infect humans in a laboratory? A commonly used gain-of-function method to optimize the COVID virus would have been to serial passage in a laboratory on a humanized, genetically modified mouse that can develop a human-like pneumonia. You take 20 mice, you infect them, you wait a week, and then you recover the virus from the sickest mouse. Then you take another 20 and you do it again, and suddenly you're starting to kill the mice. And finally, after several weeks, through this directed evolution, you'll produce a mouse that can kill every humanized, a virus that can kill every humanized mouse. The WIV has acknowledged that for several years they've worked with humanized mice developed in Dr. Ralph Barrick's laboratory in North Carolina and funded at U.S. taxpayers' expense. Between 2015 and 2018, I don't remember the exact year, but they published papers on playing around with ORF7, changing it to see how the interferon response was. And I think they had like 3 or 4 different, high interferon, low interferon, no interferon, and this was done in another backbone, but they did that work. They did suppression of the antigens on the spike protein. They did ORF8 to show who they could kill and who they couldn't in other viruses, and so all these pieces are in SARS-CoV-2 as well. There was a paper in February of 2020, 30 scientists from Switzerland, they're probably all under 30 in their tennis shoes, and using kitchen equipment, not BSA 2, 3, or 4, kitchen equipment, they were able to order the pieces of SARS-CoV-2 from a supply company, 8 different pieces, and in baker's yeast, you know, the stuff you use in your kitchen to make French dough bread on Saturdays, they were able to recover, they were able to put these 8 pieces together inside the sourdough yeast and get it to express SARS-CoV-2. So that scares you a little bit, and then you look at how many times that has been downloaded, and that paper has been downloaded 118,000 times.
But this war, we need to do something to stop the war of the future in synthetic biology and gain-of-function technology, because it could kill every one of us. There's much worse types of diseases that could be manufactured, something called a prion that our doctor can tell you about. It causes Alzheimer's and Lewy body dementia. There's no way to stop it. So some terrorists, we've seen Al-Qaeda research this. So there's so many things that could get worse.
There are three things about this spike protein that we're going to look at that tell us where it came from. The first one is called an HIV pseudovirus glycoprotein 120. The second thing we're going to talk about is what's called the PRRA insert. This is 4 amino acids, and it sits right here, and it is critical for this virus to infect people. No other coronavirus, as you're going to see on the planet, has this. No other coronavirus, as you'll see through the presentation, has HIV in it. The very top of the spike protein, what's called the receptor binding site, where it attaches to the ACE2 receptor, has changed in structure. And the structure of this part makes it a prion-like domain. A prion is something that changes the protein of something else it comes into contact, and it produces diseases like mad cow disease. Research in this country dates back to 1999 when the U.S. Department of Health and Human Services began putting money into understanding these viruses and gain-of-function research. In 2000, a gentleman by the name of Ralph Barrick, Professor Ralph Barrick at the University of North Carolina, who gets money from Peter Daszak of EcoHealth, who gets money from our federal government, Dr. Barrick began working with these coronaviruses, and he successfully used reverse genetics, where he went and rescued what's called coronavirus urbani and made a very infectious clone. That was back in 2000. In 2002, 2 years later, Barrick, Young, and Curtis, all at the University of North Carolina, got a patent for chimeric DNA. A chimer means you take parts of one animal and you combine it with parts of another animal. That's our term for what translates into gain of function. Here's the NIH grant that paid for this. NIH grant, this was 2002. In 2002, Dr. Shi Zhengli, anybody recognize that name, of the Wuhan Institute of Virology, stated that she combined HIV pseudovirus with SARS-CoV-1. In 2003, at Chapel Hill, Barrick, with an NIH grant, affiliated with NIAID, began synthetically altering coronavirus. That's the family of coronavirus. In 2006, the Chinese put together 4 viruses: HIV-1, hepatitis C virus. In 2006, they identified it as SARS-CoV-1 and SARS-CoV-2. Barrick and Chinese scientists also in 2013 isolated 3 coronavats with an HKU4 spike protein, which was unable to infect people. In 2014, our CDC accidentally exposed its workers to anthrax. It also released this deadly virus, and the NIH discovered vials of smallpox that had been sitting around for 50 years that people had forgotten about. And that resulted in the Obama administration calling a halt to gain-of-function research. In 2015, remember HKU4? Not infective in humans? In 2015, Zheng Li altered it, intentionally changed 2 mutation sites, and caused the virus to be extremely infective. This was not a naturally occurring process. She wrote in the paper that she did it. And wait a minute, it was paid for by NIH grants. In 2018, Shi Zhengli gave a presentation in a Shanghai university in November talking about the studies of coronaviruses and cross-species infection. That university has wiped that presentation from the internet. In 2019, the Wuhan Institute of Virology database wiped months before the outbreak. And by the end of the year, the Wuhan Municipal Health Commission report warning of a new pneumonia wiped. Not only did they take the backbone of one virus and attach it to the spike protein of another virus, but the research data, if you dig far enough into it, finds that they inserted 5 specific nucleotides in sequence. One of those was into the envelope of this virus, which is critical for infecting the brain. And this is how it lays out. Now, you've heard of the ACE2 receptor. It takes 4 receptors for this virus to get into you. Step 1, ACE2 receptor, right here. Step 2, TMPRSS2, transmembrane protein series 2. Third step, the furin cleavage site. That's PRRA, furin. And step 4 is neuropilin, NRP1, neuropilin-1, which helps it get into the brain. PRA is essential to infecting human cells. It's the furin cleavage site, and guess who owns the patent for the insertion of the enzymes related to the furin cleavage site? That's the insertion of it. It's us, NIH, the US government. And it owns it because it paid for it. And what's it useful for? It's useful for HIV to glycoprotein 120 and tumor progression, because this virus also shuts down the p53 system. The p53 system protects you from cancer, and this virus helps shut it down. So we've got HIV glycoprotein 120 and PRAA, and as a result of that, it causes this prion-like domain. Well, here's what we know from animal studies. In humanized mice, so that was mice that we gave ACE2 receptors to so we could work with them on this, after 2 weeks, 95% of the animals were dead. When we looked at those animals, we saw this under the microscope. This kind of looks like a sponge, right? This is what it's supposed to look like, all this. But this is what happens, and this looks like a sponge, and it's in the brain. So in medicine and science, we call that spongiform encephalopathy. And the general public calls this mad cow disease. We also know in rhesus macaque monkeys, because those are the closest thing to us to use as a model to see what will happen to us, that in 5 to 6 weeks, when the animals were sacrificed, this part of their brain was infected with the spike protein. And when we looked at their brains, we saw inflammatory cells, and we saw Lewy bodies. That's Alzheimer's disease and other neurologic diseases. These animals didn't have this before they were exposed. This is the result of the spike protein crossing the blood-brain barrier, which is exquisitely good at, and getting to its target. There's a doctor, a PhD by the name of Kevin W. McCarran in Japan, who's done more research. He is probably the world's expert on animal models, on primate models, and these diseases. And for a year, Dr. McCarran has been warning the world that this is going to have, that this spike protein crosses the blood-brain barrier and will have damaging neurologic effects like it did on the monkeys. He's done animal models showing what happens when you damage this part of the brain, and his animal models match exactly this type of damage with neurologic disease. All of this has been brought to you by the U.S. federal government, the FDA, NIAID, Health and Human Services, the Department of Defense, and the National Institutes of Health, through Fauci, to Daszak, to Barrick, to Shangley, to produce this, the years, the monies in the departments, the Department of Defense, Health and Human Services, the National Science Foundation, the U.S. Agency for International Development, the Department of Homeland Security, the Department of Commerce, the Department of Agriculture, and the Department of the Interior. This very specifically says the methods and composition for chimeric coronavirus spike proteins. I don't know how more specific you can get. This is an international patent. That means you get a U.S. patent first to alter the spike protein of coronaviruses. And look who gets paid money from this. NIH. Because they put grant money into it. Not one grant, not just a little money, not just a couple years, decades, and over $61 million, more than half of which was by the Department of Defense, who not only provided money, but provided a military advisor, David France, who was former deputy commander of Fort Detrick. And for those of you who don't recognize Fort Detrick, it was a biological weapons facility. And they changed the name for it. It sounds better. It's kind of like Offutt Air Force Base has its name changed from SAC to something more benign. But if you've ever been there, trust me, I used to live in that area, it's not benign. It's a military base. You don't put a level 4 virology lab in the center of a city We put things like that way out away from you because there's going to be a leak at some point in time, and the last thing you want is for it to leak out. Really, let's be honest, the last thing you want is for you to figure out that it leaked out, okay? It's CYA, right? But the good part, the altruistic part, is we don't want to harm people, right? So you kind of hope that there's a balance in there. Why would you put this monstrosity in the center of a city? Part of the work we were doing up front was to connect with Dr. Yan, who escaped from Hong Kong, has done interviews with me where she has pointed out that and you've all heard about this, the wet market, that this bioweapon was intentionally taken and released in the wet market to see what it would do.
I mean, it's so terrifying that I can't even process it. In the Chinese Declaration of 2011, they talked about, to the Biological Weapons Convention, they talked about systems biology further revealing population-specific genetic markers that can yield an improvement in levels of human health, but also can create the potential for biological weapons based on genetic differences between races. Once hostile elements grasp the difference between different ethnic groups harbor intrinsically different genetic susceptibilities to particular pathogens, they can put that knowledge into practice and create genetic weapons targeted at a racial group with a particular susceptibility.
Study of systems biology in the body can also create the potential for biological weapons based on genetic differences between races, end quote. That's from the Chinese document. Fourth, the document states drugs can be administered through aerosolized inhalation, which can benefit in recuing recipient noncompliance, effectively spreading pathogens and disease-causing genes, end quote. Fifth, the document states, quote, foreign genes or viruses can be introduced into the target population asymptomatically, enabling a biological weapon attack to be mounted covertly. Almost every troubling aspect of COVID-19 is discussed in this very document. Dr. Asher, do you believe that China has a biological weapons program? And if so, what is the percentage of the chance that this virus was designed as a biological weapon?
Well, China does have a biological weapons program. It does involve synthetic biology and gain-of-function technologies, which is why it was particularly distressing to learn that we were providing material aid through financial assistance, scientific knowledge transfer, as well as just complicity.
A further concern has recently come to light that the Chinese Communist Party demanded that the NIH delete the early sequences of COVID-19 cases from their database. The Chinese Communist Party demanded that the NIH delete the early sequences of COVID-19 cases from their database.
The Chinese, again, had told us in 2011 that this was going to happen. They told us that they were going to pursue, in effect, these types of capabilities because they said that's the future of warfare. Well, today we at state and other government agencies, including commerce, know this. But we have no export controls on gain-of-function technologies from the United States, even into communist China. This was basically aiding and abetting an enemy adversary, a national adversary. And what we found truly disturbed us. The Chinese were working on a military-supported program, which they did not declare under the Biological Weapons Convention, so they lied. It involved coronaviruses, which they said they weren't working on at the Wuhan Institute in their declarations to the Biological Weapons Convention. Mysteriously, at the same year in 2016-2017 period, that they stopped declaring coronavirus research as occurring at the Wuhan Institute, they kicked off the classified research with the PLA, the People's Liberation Army. In terms of creating this pathogen, I think that the chances are that they were working on it and it was funded by the military. I'm very confident in that. But whether they released it or not deliberately or just had an accident, I think the answer is they probably had an accident, but that doesn't matter because they allowed it to be weaponized in the wake of its release.
As Representative Scalise said, this is the Chernobyl of virus research, and it should underscore the need for increased scrutiny of gain-of-function research anywhere in the world.
But I do want to raise another dirty little secret that really needs to be looked at by Congress, and that those export controls should also include Americans' DNA sequences. This is a really vital piece. In general, even the NIH often exports gene sequencing for many of our people to China. China absolutely keeps databases on what in our genes, what are our susceptibilities, is there a possibility of ethnic weapons? However, China does not allow any sequences of Chinese out of their country. There's a reason for that.
So if you go on the internet and want to do, you can do DNA tests for almost anything on the internet as a consumer, and you don't even need, a doctor to sign. And you do a scrape, you do a spit. The specimen will very often go to a laboratory here, but then it gets shipped to BGI, which Dr. Asher will say bought more Illumina sequencing machines than any place in the world, and so they will do the sequence there, and they'll send it back to the company. But guess what? They'll keep a copy.
The Biological Weapons Convention has been violated. The State Department should not have said that it's case closed and we should not continue a Biological Weapons Convention investigation into a violation. There has been a violation quite publicly, actually, that they had said in their 2011 Declaration of the Biological Weapons Convention and other places, including speeches by their generals, was related to their future of warfare, of hybrid warfare. So, of course, they were working on dual-use research of concern. It's called DIRC. And the DIRC, in this case, again, if it gets out of a lab and it's not contained promptly, could result in a weapons-like release. Okay, whether they deliberately did it is, I have very little sense they did. But were they deliberately working on developing the capability to use advanced pathogenetic capabilities of war in a way that no one's seen ever employed? Yeah, they were. Of course they are. That's what the Chinese have been talking about publicly. So, I mean, there shouldn't be any surprise here. I just don't know why no one paid attention to it.
A lot of what you're seeing as attacks on me, quite frankly, are attacks on science. So if you are trying to, get at me as a public health official and a scientist, you're really attacking not only Dr. Anthony Fauci, you're attacking science. 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 Science.